In this video, I'll be going through the basics of reading drawings. So in construction, one of the most important parts is that you know how to read the construction drawings, because if you can't read them, you can't do much else. So one of the first assignments that we do for the semester is just to make sure that the students are acquainted with the drawings. We teach a 300 level course, so students typically will have already taken a reading drawings class and have usually worked in the field by the point they get to our class. However, not all have. So this assignment goes through the very basics of reading drawings and the different parts that they will need to know in order to excel in our class. So this is the student version that you're seeing right now, and I'll be working off the answer key in a minute, but I wanted to show the different kinds of questions that we ask and what we consider to be most important. A lot of this is also geared towards understanding how the drawings are laid out, because even though you might not know what something means, if you know where to go to find it, then you're golden. So first of all, we uploaded a very specific set of plans for this assignment. So I took a set of plans that was about 120 pages and broke it down and created a file that was only about 15 pages. That way it's easy to navigate and the students weren't overwhelmed when they saw that there were 120 pages they had to go through. So this is about 25 questions, I believe, and it takes the students through a set of plans. So this is called Planet Mazda. So anytime I'm saying Planet Mazda, that's the name of the project. So the first thing students need to do is find out where to expand abbreviations. There are so many abbreviations in construction that there is no way that one person can know all of them. They change with different companies, they change with different sets of plans on different projects. So understanding what the abbreviations mean is a really important part of being able to read drawings. Next, construction drawings are filled with symbols. So I took snippets of different symbols, and these are directly from the set of plans that we're going to go through in a minute, and students just have to tell me what they mean. Because if you don't know the difference between this and this, or these two, which are both ones, but one is in a diamond and one is in a triangle, it's going to make it much harder to understand the drawings. Now we're going to move down, and we're looking at the different images. So there are different symbols like these, and then there are different shading and different material symbols. So this right here, the squigglies, means something different than the hash marks right here, which means something different than all of these dots right here. So we're going to get through that in a minute. Next is just basic questions. So it's a little bit of a Where's Waldo, but it helps you know, okay, which section do I need to go for this? So the building envelope passed code inspection by what percent? Are these drawings SD, DD, or CD? And we'll get to that in a minute of what the three of those mean. Linear footage of 4-inch PVC domestic water line required. What is the ordinance number for the City of Las Vegas fire hydrant requirements? What is the total number of parking spaces between the existing car dealership, the new car dealership, and the sales inventory parking? So as I said, this project is called Planet Mazda, Mazda meaning the car company Mazda. The restrooms shown at grid lines E and 5 on page A2.02 have a detail called out. Where would you find the detail? So this is also going to introduce students to being able to precisely locate a single thing on a drawing using the grid lines. Construction drawings obviously have a scale, and the scale might vary by page, or even on a certain page there might be a couple different scales. So that's one of the most important things to look at, especially in an estimating class. So we're going to look at the scales. Then the service bays, how wide is each bay, so finding dimensions. The total length of the north wall from oil storage to the end of the service bays. So this is being able to pinpoint different areas and find dimensions. The height of the building at the tallest part, that'll get us into elevations. What is the FFE? On which side of the building are the 4 primary signs? So this is all to do with the elevations. What material is the door to room 124? Who is the manufacturer for the insulated service door? Notice insulated is underlined. What is the frame required for window type D? Which window has a P8 finish? So all of these are going to introduce the door and window schedule. Who is the structural engineer? Is going to tell us who to contact if you have a problem or a question. Live load requirement for the floor and stairs. Footings are designated based on the net allowable soil pressure of what PSF? And for a typical column base, what's the minimum concrete cover for structural steel below grade? So all of these are going to get into the structural notes and the structural details. Also this one, for joints on slab on grade, what's the maximum allowable time to pass between placing the concrete and cutting a contraction joint? 12 areas on the foundation plan which indicate a thicker foundation requirement. Identify where they are located and why the thicker slab is required. So identifying where it's located is easy. The why it's important is kind of getting the students to think about the project, think about where those slabs are, and why it might need to be thickened only in those specific areas. Then what is the reinforcing requirement for CF6? So students also need to know what CF is, and then where to find the sixth one, and then also to find the reinforcing requirement. Different types of lines on a drawing will mean different things. So this is also kind of going back up to the symbols and the different designations on the drawing. So we're going to get through the different types of lines. Then we're going to actually do a takeoff. So this is intended for a construction estimating class. So we give this to the students at the very beginning of the semester, really without the expectation that they know how to do it. However, we wanted to see kind of where the class is. Another thing that we ask students to do is to spend no more than 1 hour on this assignment. So our class of about 100 has a very wide variety of the amount of experience, the different majors. We have a few people that have only ever taken construction classes. We have a few where this is their first construction class. So this really just gives us a baseline of where they are in the class with reading drawings and being able to understand what they're looking at if we give them a set of plans. So we tell them take 1 hour at the most to try and solve this and then see where you get. We're now going to move on to the plans. So I'm going to walk you through those real quick. So these are the Planet Mazda plans. So this is a 14-page document is all. And I'm just going to flip through real quick. So there's a rendering, there's the different contacts. Then you've got your first page with all of your general notes. And I'm just going to scroll through so you can kind of see what we're looking at. There's a cover sheet, more notes, site plan, then floor plan, elevations, windows, doors, notes. So I really just tried to take at least 1 or 2 pages from every section, just so that students can understand better what they're looking at if they're given an entire section. So in order to start with the basics, I'm going to go to a little PowerPoint we have that goes through just kind of what are construction drawings? How is it broken down? You know, it's like a book kind of. So basics of reading construction drawings. So there are different sections within a set of documents. So you have your civil, architectural, structural, mechanical, electrical, and plumbing. These are also going to vary by the drawings. So pretty much every set of plans will have these, which is why we included these. These are the main 6. However, it's also very common to have your fire protection, to have your site work somewhere different, to have your landscaping. And there's a lot of different things that can go into it. And we'll get into knowing what section you're in just a second. So we're first going to start with our site drawings. So notice that it goes site drawings C. So each page, if I bring up the drawings again, each page will have a little note in the bottom right, G 1.01. That is your page number. So G means general, and 1.01 tells you the page. So if I tell you to go to M 2.02, that means mechanical 2.02. So you can see they kind of go in order, G 1.02. And then here we have an entirely different one. So this was done by a consultant. So this is for the landscaping. And we're going to get into another one, and see it says 2 of 7. However, since I snipped them all together, we don't have most of these. Then we get into A 1.01, so these are your architectural. Here's more architectural, see we jumped quite a bit. Then you've got more architectural, architectural again, and again. And then we get into S, which is structural. So this is the structural 0.01, which usually indicates a cover page of some sort. And then we have 0.11 and then 2.01. So now we're getting into the real meat of it. And then 5.01, and that's all I took from these drawings. But that'll tell you what page you're on. So it's really how the drawings are organized. So we have the different sections. So we're going to look at what site drawings might look like. So here's an example of a site plan. So when looking at this page, it's pretty hard to read, but you can still see in general, this is a very zoomed out site plan. So this would be used if you need to know where to put a trailer, or if you need to know where egress is, or if you're trying to basically just do your site plan. So this right here, that is your building. So just that little area is what you're going to be constructing. Likely this line, and I apologize, it's hard to read, this line is going to be where you're allowed to be on site, so that's going to be your fence basically. And then all of this will be the surrounding area to let you know what's around it. So it's great if you know, okay, I'm building this building right here. If you don't realize there's an airport a mile away, it's going to be problematic. If you don't know what is in your surroundings, there's going to be a lot of problems that are going to arise later. So the site plan tells you what is around my site that I need to worry about. This next one is architectural. So your floor plans, elevations, and sections. So here's a floor plan. So this is your building only. So there's no site, there's no anything except for the building. And this will give you the majority of your dimensions as well as your room numbers, your overall plan, different materials that are going to be used, and we'll get to that a little bit later. But this is really going to be the bulk of where you spend your time in these drawings, especially if you're an estimator, because you would use something like this to know, okay, this is concrete right here. That's concrete. This is all masonry, so I need to do a masonry takeoff for that. This is how many doors I have. This is how many windows I have. This gives you the bulk of the information that you need. In addition to the floor plan, you have elevations. So the elevation is basically standing on the street or standing and looking at the side of your building. So this is the rear elevation, which usually these will be north, south, east, and west elevations, just so that you're never mixed up with how the building is set up. But this one has it sectioned as the rear elevation, the right side elevation, and the left side elevation. So we'll get more into the elevations when we get into the assignment. However, just know that an elevation means you're looking at the building as if you were standing next to it. Then you have your cross section. So elevation views are only from the outside of the building. Your cross section views would be if you were to cut your building in half and be looking at it. So this is looking from a certain point, and we'll get into the different cross section designations in a little bit. But a cross section is if you were to splice your building in half, or maybe just take a certain room or something like that, and it will show you a very detailed breakdown of that room. So you have your different cross sections. Then you have details. So details are going to be in areas that need special attention. So oftentimes something like an ADA restroom will have a specific detail to it, because those dimensions have to be very precise. Anything which needs special attention will have a detail. Then you get into your schedules. A lot of people confuse this with a time schedule. So this is not saying I need 4 months to build a project. This is a table that outlines the pertinent information typically for finishes, doors, and windows. Those are the most common. So it'll say something like Office 1, Room 101. Then it'll say West Wall, paint. East Wall, paint. North Wall, glass. Something like that, where it tells you the finishes for each room. Then you have your doors, because there are numerous different kinds of doors. They might have different finishes. Some might be metal while some are wood. So it'll say Room 101, office, door, wood. Or it'll say room, whatever, kitchen, double swinging metal doors. And so those will all be abbreviations also. So you'll have to know how to get back to the abbreviation section. And then it'll tell you the different kinds of windows that are in the project. So this is a good example of different windows. So it looks like there's only 4 types of windows. That, or there's another page which isn't included here. And so if on the plans you see window type B, you know it means this kind of window with these specifications. After we get through the architectural, we're going to move on to structural. So you have foundation, framing, details. So you'll see there's a lot of different things that are similar. So there's structural details, architectural details, mechanical details, and there's going to be a lot of different repetitive things. So once you know the difference between a detail, a section, an elevation, a floor plan, your grid lines versus your dimension lines, it's going to make it much easier to navigate the drawings. So this is the foundation plan. So you can tell it looks very similar to this floor plan up here. So there's the floor plan, and there's the foundation plan. So it's the same building, except this one, instead of showing you what it looks like above ground, shows you what it looks like underground. So this is your structural foundation, and we'll get into a little bit later reading this and what the different kind of lines mean. But just know that there are different areas you might find your dimensions. So this one has these dimensions here as well as here. So there's multiple areas to find information you might be looking for. However, there's going to be a central area to find it. In addition to the foundation plan, there's also going to be a structural plan. So this is structural framing. So this looks exceptionally confusing with the sheer number of lines on here. The roof framing plan, which this is, as you can tell right here, is typically one of the hardest to interpret because there are just a bunch of lines going everywhere. So these are section lines, these are dimension lines. It doesn't look like there's any grid lines, but there might be going through here. Then you have the different ones that actually indicate the metal framing. You have the ones that show you where the rooms are. So understanding the different lines is equally as important as being able to read what it says. Now we're going to get into mechanical. And so in our estimating class, we don't have the students worry about mechanical or electrical or plumbing because there are separate classes which focus on those. So I'm going to go through these real quick just so you know how to read them, but we're not going to focus on them at all. So here's an example of a mechanical plan. So again, this is your building. So these are your notes up here, and we'll get into notes in a little while of how to know what it corresponds to. But you can see this is all of your ductwork. So going all along here and here, all of this is ductwork. So this takes that floor plan and basically overlays all of your HVAC system, which is heating, ventilation, and air conditioning, HVAC, or HVAC as it's also called. Then you have details over here of how it needs to be set up, and then you have details over here about how everything should be set up and should go together. Then a plumbing plan looks very similar, so again, that's your building right there. You can tell it's always about the same shape, so you start to kind of understand it. And then it shows all of your plumbing lines. And this is a good example of what a plumbing riser diagram looks like. So it basically puts all of your plumbing into a 3D view of the building. So how it goes down here, this is actually, think of like a 3D cube you might draw. This is actually going down. So this is going to be on grade, and then that is going below grade. So that needs to go into your foundation. Then we're going to get into electrical real quick. So here's your building. You can see the same shape again. Then this one, see it has this little extra area. This is going to be a porch or something that needs to have lights. It might be an entryway or a backyard or something like that. I'm not actually sure what kind of building this is, but it's going to show you all of the different connections that are needed. So each one of these rectangles is a light. And we'll get into this a little bit also on the Planet Mazda ones, but these are all the lights, and then the lines between them show the connections. So all of these different ones, so that's a light, a light, a light, a light. These are all lights, and if you look closely, I don't know how good the resolution is, it has an X through it, which indicates a light. If you're looking at a reflected ceiling plan, you might see ACT squares, your acoustical ceiling tiles, and they'll look just like this, except they won't have an X. So that X means it's a light. So then keep going and you'll see these are also lights, so that's a different kind. And it looks like there's a schedule here and here. They're just very hard to read because it's very poor quality, but these will tell you, all right, this rectangle means it's this kind of light. This circle means it's this kind of light. This square is this kind. So it really breaks it down so you know, all right, if I have 18 of these rectangles, it means I have 18 of this light fixture. And then we'll keep going. And so we're going to get into this alphabet of lines. These are the three you really care about. So an object line is completely solid. A dashed line is a hidden line. And a center line or column line, and typically grid lines, will be a long dash, then a short dash, then a long dash, and it'll repeat. So a good example is this one. So it's kind of hard to see actually. I don't like this one as much. But the center line, which is also indicative of a grid line, is a long dash, a small dash, a long dash, a small dash. So that is a grid line. It's giving you a reference point. The hidden line here, is pointing to this dotted line. So this dotted line means that something is there, but you can't see it for some reason. So a good example of this is if we're looking at an architectural plan right now, your floor plan, you cannot see the foundation that's underground. The foundation is still there, you just can't see it. So that's what this is right here. So a foundation or a footing, so that's a continuous footing going all the way around, will be hidden unless you're looking at the structural plans. And then this dark line means it's an object. It's something you can actually see. So right here, it kind of looks like it's pointing at the dash one, but the object line is actually this solid one that goes all the way around. So here's another hidden line. So it means that there are going to be columns right here. So that's what this is right there, is a hidden column footing. So that's pretty much what you need to know about the lines. So that's the end of the PowerPoint. So now we're going to move into the actual assignment. So when going through this, I'm going to bring up the actual answer key instead of the student version. So here's our answer key. So what I'm going to do is read the question, and then we're going to go to the drawings, and I'll show you where I found the answer. So a lot of these will actually have the answer right there, but it will tell you where you want to be looking for it. So we're going to start with question 1. Expand the following abbreviations. So looking at this, your abbreviations will be found pretty much on the first page. So I'm in the general section here, and this is where all this writing is. So it's pretty easy to read through it real quick. General notes, not what I want. Project directory tells you who's in there, not what I want though. Symbol legend, since we looked ahead on this assignment, we know we're going to need that in a second. So kind of tuck that in the back of your mind that that's where the symbols are. And then we're going to go back because that wasn't what we wanted. So we've got sheet index. So this is a really important part actually of the drawings, is knowing what sheets should be included. So clearly you don't have all of them because you only have 14 pages in this version, but this is telling you what sheets should be in there if you have a full set. One of the most important parts of being an estimator is checking to see if you have all the sheets, because if you're missing one of these, it could mess up your estimate by a lot. So before you sign off saying, yes, I have received the drawings, just flip through real quick and go, all right, do I have A401, A411, A412, A501, A502, and just flip through to make sure you actually have everything. Also, keep in mind how these are organized. So this is a really good way to see it. So here's your architecturals, which all start with A. Within architectural, you have subsections. So ADA is the Americans with Disabilities Act. So that is all of your accessible bathrooms, all of your wheelchair ramps, your signage, things such as that. So you have ADA 1, 2, and 3, so those are your ADA details. A 0.01 is existing, and then a 1 point something shows your site plans. A 2 point something, which you can see there's a lot of them, is going to show what your actual building looks like. Then you get into a 3, which is your ceiling, so reflected ceiling plan and ceiling details. A 4-point something is all of your roof. A 5-point something is exterior. 6 is your building sections. A 7 all the way through is all your wall sections. 8 is your doors, 8 is your doors and windows. Then 9, finished material, room finish schedule. Then you've got all your interiors. So 9 is really all of your finishes and interiors. And then 11 is just anything miscellaneous. So it's broken down pretty straightforward, but keep in mind this will change for all of the different jobs you're on. So if you're looking at 3 different drawings, they're all going to be somewhat similar with what goes into architectural and what goes into structural, but they're going to be numbered differently depending on the company and the architect. So going back, we're still looking for those abbreviations. So we're going to go through here. It's not down there. That's all blank. This is your vicinity map, so it actually shows you, all right, here's your project location, very small. Here's everything within a blank mile radius. So you know, okay, there's an access road over here, there's an airport over here. So it'll really tell you what's around you. Then up here, your code analysis. So this is to see if your building is actually up to code. Then you've got a plumbing analysis and the maximum quantities of hazardous materials that will be stored and or used in the building. So depending on what you're building, you might have hazardous materials. This is a car dealership, so it's probably not going to be much, but if you're doing something like a research lab or a hospital, there could be hazardous materials that you need to be aware of. Then we're going to move down. So here's the building envelope calculations. So this you also know you're going to need a little bit later because we read through our questions ahead of time. That's also a really good trick with estimating. Sometimes it works best to work backwards. So instead of going through this one by one, read through all of these and think, oh, down here I know they asked for the building envelope calculation. So I know I need to remember where that is. So that's also a good idea if you're going to use RS Means or some other pricing tool like that. Look at the unit and then do the takeoff. So I get into that in some of my other videos, but keep that in mind. So we're going to keep going, and we finally get to our abbreviations. So this is what we need to answer the first question. So it's pretty straightforward. You've got first symbols, then A's, B's, C's. It's just alphabetical. So the ones I specifically asked for are AFF, which in this case means above finished floor. And that's one that I chose, and most of these I chose because they're some of the most common. So AFF is used in probably every drawing you will ever see. So it means above finished floor. So a good example would mean that this building is 122 AFF, which means it is 122 feet above finished floor, which basically tells you the height of the building, which we'll get into a little later. The next one I asked for was BM, which can mean a couple things. So it can either mean benchmark or beam. So I didn't specify which it was, so either one is okay to answer. CJ is the next one, which is control joint. So that will be something used with your structural notes typically. Architectural will reference it so that you know how to build around it if it needs to be incorporated into the building. But where it really matters is your structural notes. So then we're going to get into CMU, which is right here, concrete masonry unit. So that's if you're using concrete blocks to build your building. Then FOC is the next one. So we're going to go up here to F, and FOC means face of concrete. Next one I asked for was RD as your roof drain. And then GSN is the last one I asked for. And that one's a bit tricky because it's not on here. So that is something that is a very, very common abbreviation used in construction, but it's not really written anywhere. But GSN means General Structural Notes. So on different pages, there's going to be different notes. So if I go down here to my architecturals, I've got general notes and keynotes. So there are notes all throughout these drawings. And your GSNs are your general structural notes. In this case, it was structural general notes, but it means basically the cover page before you get into the actual floor plans and the drawings and whatnot will just have a ton of notes. And these notes have a ton of information that you need to know. So it's going to have different requirements for something like reinforcing steel, for your foundation, specialty items, your general notes. So this tells you, all right, you know your building is concrete, but now I need to know what are my reinforcing requirements? How long do I need to wait before saw cutting? Different things like that. What are my ASTM requirements? So your GSNs have a lot of information. So I wasn't necessarily trying to trick the students, but it's something that they need to know is if a note says refer to GSN, it means refer to your general structural notes. All right, so we got through the first one. So now we're going to move on to here. So your different symbols. So I mentioned that we passed those, and those were taken from right here. So I'm going to split the screen real quick so that you can actually see which ones I'm asking for and which ones we're looking at. So the first one right here matches that, which means it's a section number. So that is a section indicator. We're going to get into that in a little while, but when you see that on a plan, this little section right here is going to be much longer. So it's going to essentially splice a building. So going through the PowerPoint, I mentioned the different sections, and that's how you know if something is a section number. This top number will tell you what section it is, and the bottom number will tell you what page to find that cross section on. So it's almost identical to a detail, except a detail doesn't have that arrow. So the detail is the next one, and it's right here. So then we're going to keep going, and instead of going through these, I'm just going to go through all of these. So you have your elevation. Looks very similar to a section, but this is telling you instead of cutting the building in half with this line, I'm just looking at this whole building. So this is going to show you basically all of it. Then you have a door number. So a circle with a number in it will mean a door number. If we skip ahead a little bit, a hexagon with a letter is a window type. So knowing the different kinds of shapes will really help. This is a handicap sign. Sorry, we went a little bit further. This is your elevation line. So you need to know what elevation your building is going to be at, and different parts of the building might have different elevations. So that will tell you what is your elevation. These are your construction notes. So this is one of the most common symbols. So I'm actually going to jump ahead and show you what that might be. So it's a diamond with a number. So if I jump ahead to your actual plans, so this is a great example. So all of these are all notes. So every one has a different number and it points to a different thing. And if you scroll over, they all correspond to these keynotes. So again, it kind of shows you up here the little diamond. So if I go right here to this one, number 5, all right, I don't know what number 5 is. I don't know anything about this right now. So you scroll over to number 5 and it tells you it's a metal panel, MP-3 typical. So TYP means typical. So then you know, all right, anywhere that there's the letter 5, it's a metal panel. 13, we don't know where that is. It's a little tiny thing sticking up right there. And you know it's signage. So you're looking at the side of a sign so it looks completely flat. But if you go over here to the other sides, so we're on our elevations right now, you'll see there's the signage again, and there's the actual sign itself. So you're looking at this drive center sign right there from the side. So if you zoom in there, you'll see that 13 again. So that's what a keynote is, and those are imperative when reading drawings. So we're going to go back up and go through the rest of these symbols. Alright, so the next one is an interior elevation symbol. So it's a little bit different than this one, which is an exterior elevation. These aren't as common. Typically, it'll just be section numbers instead of interior elevations, but it's good to know if you do come across one. Then you have existing structural, so it's a hexagon with a number. So keep in mind this is a hexagon with a letter for a window type, a hexagon with a number. It's existing structural. Then you've got new structural, a circle with a number. So instead of existing, this is new. And this is very similar to your doors. However, if you look at the number, all of your doors will be in the hundreds or will be 3 digits. So very similar designations, very different meanings. It's also good to just use a little bit of common sense when looking at the drawings. There's going to be a lot of different door numbers. They're probably not all structural callouts. So if you have numerous of these, and they all seem to be in doorways, they're probably not structural. This will be an equipment note, a revision note. So this is a good thing to know, because if you get different versions of a set of plans, it's going to change different areas of a building, and it might change them enough that it's a drastic difference. So let's say they take a bathroom that wasn't ADA compliant and they make it ADA compliant. That is going to be a very big revision, and it's usually also going to have a cloud around that area. Unfortunately, I don't have an example of that in these drawings that I'm aware of. We might come across one, but it will look like a cloud, and it will have a revision note saying change bathroom to be ADA compliant, see detail, whatever. So it'll tell you, hey, this changed, make sure you notice this. The next one is to just tell you what a room name and a room number are. So you have an open office 100. A good thing to note is that your door number and your room number will typically correspond. So if you have office 100, it's usually going to be door 100. If, let's say it's a conference room, so you have conference room 208. So this will say conf room 208, and a conference room might have 2 doors. So the door will be 208A and 208B, or 208.1, 208.2, something like that. Usually the door numbers and room numbers will correspond. All right, keep going. We get concrete tilt panel elevation. So if this is a tilt jaw, which I assume it is since this is in the symbols, it's going to tell you the different panels and where to find the elevation, which means looking from the side of that panel. I cut all of those out of this in my little 14-page version, so we're not going to worry about this. And then you have GFRC profile. And a GFRC profile, I'll tell you, even I had to Google this. There are so many different abbreviations for different plans and different everything, is glass fiber reinforced concrete. So this is going to be a concrete structure, which we'll get into later, looking at the different shading of the drawings. But if it has a circle and a letter, it's the GFRC profile. All right, so now we're going to get back into this. So I went through this top row and this bottom one, but I never saw these ones. So we just went through all of the different symbols, but never saw these. But as I told you, I took all of these straight from the drawings. So something to note, those were architectural symbols. Now we're going to move down, and we're going to get to the structural ones. So each different section will have a cover page with new abbreviations and new symbols. So that's a really good thing to keep in mind, that if you're missing some sort of abbreviation, it might be in the structurals instead. So a lot of these are going to be similar, like CMU, Concrete Masonry Unit. That was in the architectural as well, but a lot of these won't be. So keep that in mind. And we're going to go over to these symbols, and now we can find these ones. So this is a change in elevation. So this will be used most commonly on something like a curb in your parking lot to show you how tall the curb needs to be, or maybe on a staircase, but that's less common. Elevation indicator is very similar to what was shown in the architectural ones, but just to show you there's a couple different ways it can be drawn. And then an arrow, which most people don't realize, is a slope. So the most common slopes are going to be on your roof or in a parking lot where you need to slope it towards a drain. This is a car dealership, so I'll tell you there are going to be floor drains in various places in case oil spills or in case they need to wash something like that. And it's going to show sloping. It will also be in every bathroom because there's always a floor drain in the bathroom. If there's a shower, or if you're doing a research lab that has one of those emergency showers, you're going to have to slope it. So just keep that in mind, that different symbols, even though that you might just think, oh, it's an arrow pointing towards something, that might not be the case, and it probably isn't the case actually. So real quick, we're going to go through these again. So this is a ramp. So if it has this dot at the end, that's specifically showing a ramp such as ADA, or maybe it's a loading dock or something. So this is going to be a very gradual slope. If it's this one, just enough so that water goes, but not enough that a person walking on it would really be able to tell. This is going to show you a span, so I'll get into that. That'll be done in primarily your roof framing plan to show you, all right, this whole span is going to need this kind of joist or something along those lines. Then you've got steel elevations, miscellaneous elevations, floor or steel elevations. So anything that looks kind of with the feet and the inches, probably an elevation or a dimension. Then required number of headed shear studs, rigid connection, camber up, elevation indicator, we went through that one. Step and continuous footing indicator. So this would be something, a continuous footing we're going to get to, but it basically is that dotted line I showed you in the PowerPoint. So it's all underground, it's a footing, and it just means instead of being an isolated footing where it's, all right, this is 2 feet by 2 feet to support this one specific thing, it's a footing that goes around the entire perimeter of your building, essentially anywhere there is going to be a building on top of it. Then we get a little bit more into symbols and abbreviations specifically for concrete, and then up here we have a list of our drawings. So that's everything for the symbols. So now we're going to go back in here and see what's next. Alright, so just cruising right along. We're now on number 3, which has these different, they're not so much as symbols, so much as shading or coloring, or, I mean, I guess you can call them symbols, but it basically is the different way materials are indicated on drawings. So these are going to be the same throughout all of your drawings. So it doesn't matter what your company is, doesn't matter what the project is. There might be very slight variations. However, for the most part, these are going to stay the same. So I'll tell you that the squigglies right here are going to indicate insulation. Masonry walls, let's see how this quality is going to be this dash line, this 45 dash going all the way down is masonry. So right here, where you have that 45 dash, that's masonry. Then this one right here with those darker lines, see how it's only around that one room? If you actually look really close, it has the masonry lines under that. So this dark dash right here indicates fireproofing of some sort. So the different level of fire rating is going to depend on the room, and that'll depend on the drawing. But this is an electrical room, which means it's more prone to fires, so it needs to have a higher fire rating than the rooms around it. So that's what those dashes mean. And then if we look up here, this is concrete. So when it's got those speckles, that'll be concrete. So you can tell this by looking at the drawings. So a pretty good way to tell is if you go to the details. So that's actually where I got these from. So this is that exact detail. I did tell the students that all of these snippets came exactly from these drawings, so they can just search for that exactly. And this 8 down here is pointing towards the concrete. So it's kind of speckled with little triangles. So we don't know what that is, but we know that's a keynote. So we are going to go over here to our notes and look at 8, and it says concrete floor. So anywhere you have those speckled, especially if there's the little triangles, is a concrete floor. I challenged students to see if they could figure out what the rest of this is. So just kind of looking at this, you now know it's a threshold detail, but this is flat, and then it gets kind of raised, and this is floating. So if you think about this for a second of what could this be where it goes from flat to raised with something floating. So this is a door. So this is a doorway. So you can tell that by looking, all right, so number 9 and number 11 and number 10. So what are those? Go here. 9 is VCT as scheduled, which is vinyl composite tile. So it's pretty typical, especially in like apartments or new office buildings, where it's that fake wood looking stuff, but it's actually more of a tile than it is wood. So it's basically fake wood. Then floor transition strip as scheduled. So that was where this 10 is right here. So see how it's just raised very slightly. So that's going to be a little bit, it's often called a Schluter strip because that's the most common brand. So it's a little tiny metal strip, and you probably never noticed them, but if you start looking for them, they're everywhere. And it's just to create a smooth transition from the tile to 11, which is carpet. So this goes from the VCT to a little strip to carpet, which means that this one right here is probably a door, which it is. So Keynote 1 means a door. And so a good way to also tell, this is your door schedule. So if we knew what room this is, we could actually tell you what that door was made of and everything. So like I was showing you, this room number corresponds to the door number typically. So room 101, room 101, room 101, room 101, 101A, 101B, 101C, 101D. So they almost always correspond. So keep that in mind, but not always. So don't assume, just flip to that page and check real quick. But we're going to keep going now with the different kinds of materials. So the next one, let's move over to this insulation one. So let's see if I can find this real quick. I don't remember off the top of my head the detail. But it doesn't matter because if you can see, this is everywhere. So the squigglies will always mean the same thing. So this squiggly is either 5 or 6, so we don't know. They both look like they're pointing there. So let's go over here to 5 and 6 and see what they say. So 5, metal studs as scheduled. 6, insulation where occurs. So the 5 there was pointing to a metal stud, and the 6 was pointing to insulation. And if you're not sure, you can just keep going until you find one that's isolated. So we're going to keep going and see what else we can find. So here's some hash marks. So this is either, so the 4 doesn't look like it's there, but it's going to be 17 or 18. So let's go over here, and we're going to look at 17 and 18. Wall furring and rigid insulation. So wall furring is when you have a structural wall that really isn't pretty, or you want something on top of it so it looks uniform. So you build a bit of a half wall in front of it. So it's very common, let's say you have a masonry building, so you have those blocks everywhere, but you want it to be an office with drywall. In order to do that, you will do a one-sided wall which has no structural value and is only there because it looks good. It doesn't actually create a room. It's not a real wall. So that's called furring. It's also used, you can have column furring. So if you have a big concrete column in the middle of your building and it's not pretty and the architect wants to do like metal cladding around it or something like that, that can be a type of furring. So there's a lot of different ways, but it basically means putting something on there so it looks different. Then you've got your rigid insulation, which is actually what this one was. So rigid insulation is going to be those marks. Then 16, can you tell what that is? 45-degree marks. So we're going to go over here, and we're going to check. And 16 is concrete masonry. So that's 45-degree marks. That always means masonry. So then we're going to keep going around here. This is another threshold detail that's actually almost identical to the other one, except this is different. So if you look at these, we knew that 10 was the transition strip. 11 is our carpet. We don't know what 23 is. So see, it all looks almost the same. So here, if I pull this one up on this one, that looks almost the exact same, but it's a little bit different. So 1 is always a door, 10 is always your strip, 11 is always your carpet, 8 is always your concrete. Let's see what 23 is. So we're going to go over 23, tile as scheduled. So instead of right here where you had the VCT, you have just normal tile. So that'll depend on where you are in the building as to whether or not there's going to be tile or VCT or something along that. So we'll keep going, and a lot of these are going to be metal components, but look, that's 1, so that's a door. So this is going to be above a door. So this is going to be a door jamb detail. Here's those 45-degree lines, so that's your masonry. This is a weird looking thing. So this is Planet Mazda, so it's a car dealership. So if you look at this, what does this look like? And keep in mind this is a head detail, which means this is the top of something. So I'll tell you, this is a wall that comes down and then stops, and this is all open. This is a garage door. So this is going to cycle and pull up the door. So this is the actual motor and everything where the garage door needs to be mounted. See this box right here? That's going to be your garage door mount. So 21 and 22, let's see if I'm right. So 21, coiling door, 22, barrel shroud. So coiling door is another way to say a garage door. It can also be called a folding door or sometimes retractable door, but a retractable door typically means it goes into a wall, not that it folds up. So a coiling door is the same as a garage door. And then a barrel shroud, it looks like exactly what it sounds like. So it's going to be something to hide the barrel of the coiling door, if that makes sense. Basically, it's a box that you put your garage door into. Keep going. This is insulation, as we know. So we're going to keep going. And you start to realize, get a little bit repetitive. So 1 is your door. So you know this is a head detail. So this is above your door. Insulation. We don't know what 7 is yet. So let's check out 7. And 7 is boxed stud header, stud size, and gauge per wall type. So that's going to be your wall header. And a header is basically just something above a doorway. So that will have your doorway components. And so that's going to depend on the wall type. You're going to keep going down. That's a frame. You can tell it's just going to be metal, most likely, because it's just a solid line. That usually just means it's a metal component. Here's your different door types. So these are door type elevations. So we had our door schedule up here. Then we have some remarks. And then we have our door types. So these are your folding doors, coiling doors, garage doors, whatever you want to call them. So they're going to coil up there and they pull up. Then you have just the normal ones. So this is one that is probably into an office or something, maybe a conference room. And it's going to be wood here, and then this is glass in the middle, tempered glass. Over here, this might be into a workspace. It looks like it's ventilated. So metal louver, so that's a ventilated door. And then you've got a pretty typical door where this part is glass, but the rest of it is wood. And then one other one. So these look the same, except this is a solid wood core and this is a hollow metal core. So it's a different door material, even though the door might look pretty similar, especially when you're not looking at the door itself. It's the exact same dimensions, same pretty much everything except for what it's made of. Alright, so we're going to keep going. I kind of skipped a little bit, but it does get to be repetitive. Again, this is CMU. This is going to be a jam guide detail, so you can go through and look at these if you want to. Pretty much just look at something, and if you don't know what it is, look at the notes and read it. And you'll start to realize the more you just think, oh, what is that, and look, the more you're going to retain. So instead of saying like, oh yeah, there's some masonry and some stuff under it, go look at the rest of it and see what it is. So we'll keep going. Insulation, all metal. This is all framing, so these are framing studs. And then we've got a lot of different details here. There's a door with some windows. These are all going to be windows, I presume. Yep, so here's window type N. So see that hexagon with an N? We know that that means a window type. So a hexagon with a letter is a window type. So this is telling you, if I zoom out here, these are all window types. So there are a lot of different types on this job. So we're getting into W, V, U, T, S. I don't even know how many there are. There's a lot. And they might start to double. So you might have window type AA, or it could be A1 or something along those lines. But these are all the different ones. So anything you need to know about a window type, you'd come to this page. And under it, it tells you what it is. So it actually gives you specifics and it gives you dimensions. And these are all, as we know, details. So this is saying to see this right here in better detail, so likely it's going to turn it for you. So instead of looking straight on, you'll be looking from the side so you can see the connections. Go to detail number 7 on page A8.12. So I don't have that page in my little 14-page one, but it looks like a lot of these are on here. So this is 8, 8, 7, 7. So they seem to be a little bit repetitive, and you'll start to see that. But it looks like A 8.12 is where most of the window details are going to be. So then you keep going, and again, there's a lot of 8s, there's a lot of 8s, here's a bunch of 3s. So you'll start to understand kind of what it is. So we're going to keep going down. And that's about it for the different material types at the moment. So I'm going to move on to the next question. The building envelope passed the code inspection by what percent? So when I was reading through this, we kind of made a note, oh, there's the building envelope section. And that was at the beginning. So if you weren't really sure, think, all right, where would that be? So that would be something that needs to be written. And that's more of a note than something that actually goes into the drawings. So go up to your notes, and right here there's a whole section for it. So building envelope calculations, and I tried to make it obvious, it's this green here. Design 18% better than code. So it passes by 18%. The next one, are these drawings SD, DD, or CD? So first we need to look at what do SD, DD, and CD mean. This is technically written on these drawings. However, it's not going to be found in any notes or anything. So SD means schematic design, DD is design development, and CD means construction document or contract documents. Technically, both are used, but in this case, we're going to have CDs. So SD design. So your schematic design drawings are typically about 0 to 30% complete. So this tells you how complete are my drawings. Is this a rough sketch on a napkin somewhere? Technically that's an SD. Or is it completely ready for construction, in which case it's a CD. So DD is design development. So this is typically 0 to 30, 30 to 60, and then 60 to 100. So one way to tell, you can kind of look at this and know that it's pretty developed, but if you're not as familiar, another good way to tell is to just go to the front page and you'll see 100% construction document set. So you know it's CD. This will often say it also maybe in the bottom right corner. So something I actually forgot to go through earlier is this right hand border. So this border is always there, but it changes with what the information is. So it'll have the page number here, which I talked about. Then if you zoom in, it'll give you project information, who drew this one drawing, the date, the scale, any notes here. So let's say this is version 3 of construction documents or something along those lines. It'll say revision 3, then it might say a page number that changed, or it might say in general what changed, and then it'll give you a date. So that's very important because if you're working off of outdated drawings, things aren't going to go well. Then it tells you what it's actually called, Planet Mazda. It'll tell you where it is, and then it'll tell you what this is. So this is the overall site plan. So if we zoom out and wait for it to load, this is the overall site plan. So it tells you, all right, what am I looking at? I have no idea, but I can zoom in. Oh, this is the dimensioned floor plan. So it'll tell you what everything is on here that you're actually looking at. So these are your exterior elevations. And sometimes this will be down here, so it'll go A2.02 dimension floor plan. It depends on the drawings, but that information will be somewhere on the right. Usually it's a disclaimer or a note or something, and then a logo will go in the top. So this might vary a little bit, but if you need to know something along those lines, that's what this is. It makes it very easy when you're flipping through pages to find the one you want, which is nice because you know it's always going to be on the right side. So we're going to keep going. So we now know that these are CD, and we know schematic design, design development, construction document. So now we're going to move on. What is the linear footage of 4-inch PVC domestic water line required? So one thing to keep in mind, by this point we don't expect students to know how to do a takeoff. So a takeoff is when you take the drawings and you quantify it into basically line items. So you might say, all right, there are 82 doors that are hollow metal. There are 28 wood doors. So it's quantifying it. There are 894 linear feet of baseboards or something like that. It's where you take the drawings and actually quantify what's there. we don't expect them to do that yet. And we also told them not to spend too much time on this. So this probably isn't something that we're having them calculate. So what you want to do is think, all right, linear footage of 4-inch PVC domestic water line. So a domestic water line is going to be in some sort of plan that needs your water. So it might be plumbing, but in this case I didn't give any plumbing. So the next most likely is in your landscape. So landscape drawings, which are here, is going to tell you all of your information for some water lines. So this might be for a sprinkler or something like that. And I'll tell you where it is. It's over here. So private water, so public water, private sewer. So this is 4-inch PVC domestic water line, 568 linear feet. So we're never trying to trick students, but we try to make them think a little bit outside the box, where we didn't even give the plans, I don't think, that show that water line. Yeah, so there's no way they could have done that takeoff. But they know it's in there somewhere, so it's a little bit of critical thinking. All right, where would that water line be, and where would I find that information? So then we're going to go into ordinance number for the City of Las Vegas fire hydrant requirements. So this is also something that's going to be on your site. So this might be in the architectural notes, or it might be on your landscape notes. So since we're already on this page, we're going to look here, and I'll tell you what's also on this page. So these are your general notes. Oops. City of Las Vegas grading notes. Las Vegas fire and rescue general notes. That sounds about right since it's your fire hydrant. So we're going to go through this and tried to make it somewhat easy, and it's just the first one. All work shall be done in strict accordance with the City of Las Vegas Fire Department Ordinance number 5667. I also try to take things word for word just so there's no ambiguity in the answers, so try to take that word for word. And we're going to move on now. Where would you find the total number of parking spaces? So between the different ones, so if you're looking for parking spaces, what would you be looking at? Are you looking at your landscaping? Are you looking at structural? Are you looking at architectural? In this case, it would be something that's architectural, and it's going to be the entire site because it's not actually a building, but it's on your site. So we're going to go now down to our architecturals, and right here you can see, all right, this shows us all the parking spaces. So we're going to go down, and what you could do is count them. But keep in mind, we only gave students an hour to do this whole thing, so we're probably not going to make you count it because that is tedious and frankly a waste of time. So you could count it, or you can go right here to the site data section, and it tells you right here. Parking provided, existing, new car, additional, and then all they had to do was add up those three. So existing, new, and additional inventory for a total of 568. So just saved you about 10 minutes of counting spots and a lot of frustration. So one thing to note also though, if we go back to the site data, to kind of just go through it, this is a lot of good information. So this is your zoning requirements, which tells you how the plot of land has been zoned. Parcel area, so that's how many acres. Gross building area, so the footprint of the car dealership that's existing is 46,000 square feet. The new car dealership is 19,000, so your total. Parking required, so this is parking provided, this is parking required. So this is saying for every 500 square feet, you have to have at least one parking space. So you can't have this brand new building and not provide parking for it. So this tells you, what does the city tell me I have to have? So for 43,000 square feet at one space per every 500, you need 88 spaces. Think for a second, what is this 4HC? So this is for handicap. So of your 88, you need 4 handicap spaces at a minimum. New car dealership, you still need one every 500 square feet. So you have 20,000, so you need 39 with 2 handicaps. So they went bare minimum. And then additional sales and inventory, so you can't really actually park there. So this is good to know for constructing it, But that is not, hey, welcome to our dealership, park and come in. These are taken by inventory vehicles. So there's 441 inventory spaces. Then you can keep going to your general notes. So there's always going to be general notes, and I don't know if there's keynotes. Yep, there's the keynotes. So this is a very specific, as we've talked about, this is a diamond, this is what the diamond means. And then this is going to tell you, in general, contractor needs to verify, see civil drawings, blah, blah, blah. So this is kind of your CYA notes, which is another abbreviation you can look up if you want to. But that's what this is. It's basically a disclaimer. So we're going to go back through and keep going on this right here. So the restrooms shown at grid lines E and 5 on page A2.02 have a detail called out. Where would you find that detail? So this is whether or not you can read what this detail means right here. So I already gave you all the information. So A2.02. So A2.02, grid line E and 5. So around here, these are your grid lines. So it starts at A, B, C, D, D.9, and you might have very specific ones if they're very specific requirements. E, F, G, H, J. Keep in mind there is no I. And that is very common, especially in construction, because it is often mistaken as a 1. So I is frequently skipped. So we're looking at E and 5. It goes letters down here, and then you've got numbers over here. So we want E and 5. So we're going to go down to 5, which is right here. I'm going to zoom out a bit. So you got 5, and go over and kind of keep in mind where it is, and E. So right there, and then see that point is exactly there, but a restroom is not a single point, it's a room. So E5, and here's the restroom. So this dashed line, thick dashed line, around the entire room indicates a detail. So the detail is right here, and it's pointing to this line. So again, if you look at how it's designated, it has a line. So a detail, this line will then make a box typically around whatever the detail is. So this is telling you that on page A 2.11, detail 2 will show this restroom. So this restroom does not have any dimensions, and it doesn't have any information in it really if you look at it. So in order to find the actual dimensions needed to build that restroom, you have to go to A2.11. This X right here, you'll see later on also, this indicates a slope. So a slope could be indicated by these arrows that we showed you on the structural, but in architectural, a slope is often shown with a big dotted X, and that circle in the middle is your floor drain. So that's the location of your floor drain and how the floor is sloped to get there. So we're going to keep going now. We've got through all of these, and we're now on 10. What is the scale on the dimensioned floor plan? So the first thing you want to do is go to the floor plan. So told you can read them over here. So dimension floor plan, that's already where we are. And I kind of tried to put these questions in order, so keep that in mind also, that they might not be this nice in real life, but I tried to go in order. So dimension floor plan, and it will also say not only here, this is what the page is, but if you look over here, this tells you what you're looking at in that snippet. So if we go down a bit, this tells you these are all of your exterior elevations, but this is your exterior west, exterior north, exterior east. So if there's more than one thing on a page, there'll be something around here that tells you what it is. So especially on the details, you have detail, 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 detail. So look for that. So we want our dimension floor plan, and our scale will always be directly under this. So dimension floor plan, zoom in, and you find the scale. So we'll keep going, and I'll show you another example of that. Here's your exterior elevation west, zoom in, and you find your scale. So it's always under where that writing is. A good thing to keep in mind is that there might be an instance where a page has a scale, but there also might be an instance where a detail has a scale. So let's see if there's an example of this. I'm actually not sure if there is. But for example, I told you that A2.11 has the detail for the restroom. It's pretty common that a restroom detail will take up about a quarter of a page. So you might have a restroom detail in this section and then smaller details around it. In that case, the restroom detail will have a different scale than all the other details around it. So you have to set your scale per what you're looking at. So if you're doing takeoffs on a page and you set the scale for the whole page, but different details have different scales, you're going to be very far off. So always check and always verify, because you never know if things have just been changed slightly, maybe when you were uploading them to a takeoff software, maybe when you converted them, something like that. Always just check your scale. It only takes a second and it can change your numbers dramatically. So we're going to keep going. There are 6 service bays at the north end of the building. How wide is each bay? So what we're looking for is a dimension. We know that this is going to be an architectural because it's not a structural question. Usually dimensions will be in your architectural. So north end of the building, we have our compass down here. So we know north is going to be up, and so we're going to look. So the north end of the building, these are the service bays. So if we look, we have 6 of them. So 1, 2, 3, 4, 5, 6. How wide is each one? And it's 14, 14, 14, 14, 14, 14. So they're all 14 feet. What is the total length of the north wall? So that's going to be exactly where we already are. We need length, which is a dimension, which usually means architectural. And we want the north wall, which is exactly where we are. So we want from oil storage to the end of the service bays. So this is where students often get tripped up. Here is oil storage. Again, there's that X. You can tell that that's something that's going to need a floor drain. So there's the oil storage I'm talking about. And then all the way to the end of the service bays. So the service bays go here. So I'm looking for the dimension from here to here. What students will often do is go up here and say, all right, that is 165 feet. That was easy. However, look, it's not 165 feet because you need to look at what those lines are actually showing you. So this is that 165, and it's going from one side way to the other. So this is the pickup area for your car or where you drop it off. So this is kind of like a little drive-through area. That 166 is going all the way to the end. But I asked for oil storage to service bays. So it goes from right here over, which means you need to calculate it yourself. So that means, see right here, takes out that little drive-through area. So you go from here over, and you just need to add up that one, and that one, or you can take this 166 minus that one, and you'll get 145 feet. So now we're going to keep going. Height of the building. So something like a height, you're going to need to see it from a side view. So to see it from a side view, you will need either a cross section or an elevation. Cross sections show you interiors of the building. Elevations show you exteriors. We want the height of the building at the tallest part, which is going to mean an exterior elevation. So we need to find our exterior elevations, which happen to be the next page. And we're going to go to these lines over here. So top of TO, top of parapet. Parapet wall is, if you've ever been on a roof, it's basically a little tiny short wall that's used as a safety measure. So that's what a parapet wall is. They're usually pretty short. It can either be used as a safety thing, so if there's a crew working up there, they don't need fall protection, or it can just be used as a little border because typically you'll have like HVAC equipment and you'll have gravel and a walkway and different stuff on a roof. So it could be anywhere from 2 feet to, actually you could have a very high parapet if you wanted to. It's going to depend on the building. But basically a parapet wall is a half wall that borders the roof. So top of parapet, and then it shows you the elevation. So we want the building at the tallest part. So we're at 122 right now. So what is the tallest part? So just looking at this page, it looks like it's going to be this area here, which is the same as this area here, because keep in mind you're looking at it from all the directions. So let's just go to this one in the top because it's the most clean, and it tells us 128. However, that is not the height. That is the elevation, and we want the height of the building. So the elevation is 128 feet. Our finished floor elevation, so the elevation of the ground basically of our building, is exactly 100, which means that our building is 28 feet. Also, just think of it kind of a little bit of a common sense thing. In general, your standard buildings will have 10-foot floors. That's a really good, just rough number to use. So a building that is 128 feet tall would be probably about 13 stories. And if you look at this, this is not 13 stories. So just think about it. My building is not going to be 128 feet. So your building is 28. So that also answers the next one. What is the FFE? So FFE means finished floor elevation. What a lot of people mixed up is FF and E. So they thought, okay, that's an abbreviation. I need to go to the abbreviations. However, this one is actually so common, it's often not included. So if we go here, we'll see FF and E, furnishings, fixtures, and equipment. That is not what we're talking about here, because it also, what is the furnishings, fixtures, and equipment isn't really a sentence that you would have. You can't list all furnishings, all fixtures, and all equipment. So FFE is probably one of the most common, similar to GSN, which is finished floor elevation. So that's not only used for your exterior elevations. It might say door at 8-foot FFE. So it's going to be used many places, and it's a really good thing to know. So the next one, on which side of the building are the 4 primary signs: Mazda, Drive Center, Planet, and Service? So looking at this, which side of the building are the main signs? That's going to mean you need the exterior, and I'm kind of cheating, I already have it up, but you're going to need the exterior sides of your buildings. So in order to find that, you go to your elevations, which is where we already are, and all you do is look for the signs. So we found that Keynote 13 earlier that was right here showing a sign. There are no signs shown here. So this is the back of the building. That's that 13 again, so that's the side. And then here's the signs. So Mazda, Drive Center, Planet, Service. Mazda, Drive Center, Planet, Service. And that is elevation south. So we put south side. Next one, what material is the door to room 124? So now we're not worried about our elevations, and we're looking for a very specific thing about the doors. And doors will typically have door schedules, which happen to be pretty much right where we are, because again, I tried to go in order. So a door schedule will be set up like this: door number, room number, size, width, height, trim. So this is telling you I have a 4-foot wide, 7-foot tall door with 1 3/4 inch trim. Door type is A, so you can tell when we go down here the different door types. So that's going to be door type A. Material, aluminum. Finish, P16. That will likely be a paint. Then size, the actual size of the frame. So these are all the door, this is the frame, and this is the detail. So then you've got your frame size, your frame type, frame material, frame finish. Then details for your head and your jambs. Then the threshold, fire rating, door hardware, and remarks. So we're going to go through, and I was looking for what is the material of the door to room 124. So room 124. Right here, and I'm going to go over to material, and it's aluminum. So I put aluminum. Then we're looking for the manufacturer for the insulated service door. So that's going to be something very similar where we're looking for door information. Keep in mind I put insulated. So here's remarks. So service door, manufacturer is Marathon. However, we have an insulated service door. So this is more making sure that students are reading and really looking at the details. So the insulated service door manufacturer is the Cookson Company. Going to keep going. What is the frame required for window type D? So again, that's going to be where I showed you all the different window types. So this page is all window types. So window types and details. We want window type D. So something that's a little bit weird is it won't really seem to go in order. It'll go kind of in reverse order. So we're going to start with A in the bottom right, then move left and up. So it's almost exactly inverted. But we want window type D, so we go A, B, C, D. And we want the frame, so it's 2.5 inch by 7.5 inch aluminum frame. Then which window type has a P8 finish? So this is a little bit more of a Where's Waldo thing. But if we read this, so this says frame, then the type of system, the type of glazing on the glass, and then the finish. If we go over one, this is the frame, manufacturer, glazing, finish. Frame, manufacturer, glazing, finish. So they all go that. So you know this bottom one is the finish type. So it's none of these. These aren't P8. So we're going to go up. And we found a P16. That's not what we wanted. And there's a P8. So it's type J. And I think there's actually one other. I believe it's M. Either one is fine. So it's P8. We're then going to move on past the windows, and we want our structural engineer. So there's a couple different places to find this. So the first one is at the very top where it had the project directory. Actually, there are so many places because you'll first have your cover page, which will tell you that you have your structural engineer, MA Engineering. Then you get to the project directory, and you'll have that again. And then if you see that I'm going in order, it's probably on the next page or a couple down, but here was where we were. MA Engineering, Structural Engineering Consultants. So we want MA Engineering there. And then we're going to get into the live load requirement for the floors and stairs. So now we're in only structural information. So our live load requirement is going to be somewhere in our notes. So that's in our general structural notes. So we go down to those. And we care about the floor and the stairs with the pounds per square foot. So we go down. In general, we're not looking at any of these. And then we start to see things that are separated out. So something like a live load requirement will often look a little bit different than the rest. So see, these are just kind of big chunks of information. Then it started to go a little bit different. So structural design criteria, floor live loads, floor and stair 100 PSF. So there we go. We have our 100 PSF. Footings are designed based on net allowable soil pressure of blank PSF. So that's kind of the same question, except now we're looking for our footings. So this isn't really what we want. We're in our building right now. So we're going to move over and then start at the top again. So here's our foundation. So it's based on the geotech report. And footings are designed based on a net allowable soil pressure of 2,000. So again, I tried to do it word for word just so you never had to worry about, oh, is this what she's looking for? And then keep going down. For a typical column base, what is the minimum concrete cover for structural steel below grade? So this could be in a few places. So we're first going to look in the general structural notes. So typical column base, minimum concrete cover. So this was all of our foundation. These were our general notes. So we're going to go over and we see that this is reinforcing steel for concrete and masonry. So that's kind of what we're looking for because we want the minimum concrete cover for structural steel below grade. So you can read through all of this. However, it's not in there. So then you're going to go over, double check, specialty items, pre-engineered, not what we want. And special inspections, not what we want. So it's not on this page. which means it needs to be somewhere else in the structurals. So in order to find that, we're just going to keep going and see what we can find. So this is our foundation plan. However, this is all very general. We're looking for something very specific, the minimum concrete cover. So we're going to go down again to our notes, and this is going to look much more like what we want. And we want a typical column base. So in order to find that, again, I tried to keep it pretty much exactly what it would be, and we have typical column base. So you zoom in on that one, and we're looking for the minimum concrete cover for structural steel below grade. And so just read through around these and look until you find that. And right there, concrete cover at structural steel below grade, 3-inch minimum. So we found that. Now we're going to keep going. For the joints in slab on grade, what is the maximum amount of time allowed to pass between placing the concrete and cutting the contraction joint? So that's going to be something similar again, where it might be in the notes and it might be in a detail, but you kind of just need to look for it. Kind of tried to hint towards it by capitalizing this. So just as I said, exactly a typical column base, this is joints in slab on grade, joints in slab on grade. So I'm going to zoom in on that, and we're going to find the maximum allowable time. So saw cut 1/8 of an inch wide contraction joint at a depth of T/4 minimum. Sawing must occur as soon as concrete surface is firm enough so concrete will not be damaged, but no later than 12 hours after it has been poured. So 12 hours is the answer. We're then going to get into a little bit more of critical thinking. So there are 12 areas on the foundation plan which indicate a thicker foundation. Identify where they are and why it's required. So first off, we go to the foundation plan. So we know that's right there. And it's going to look like this. A lot of lines, a lot of dotted lines. So this 45 degree is again showing masonry. And this dotted line around is a continuous footing. So this is our slab right here. This whole thing is going to be a concrete slab. So it says concrete floor. And then 12 areas where it's thicker. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12-inch thickened slab typical. So that is a 3 foot by 3 foot square of thickened slab 12 times. So think for a second why that might be, because you have to think about your building. So if we go up again to the architectural plan, let's see where those are. They're at the north side, and they're right here. So they line up exactly with the service bays. So those are thickened slabbed because those are the car jacks that are shown. So it's the service area where they can jack up the cars to work on them. So they need to be a thickened slab to support that weight. And keep in mind, this one is a little bit different, and that's for different kinds of cars. So if your car can't go on this kind of jack, which is the most common, it'll go onto this one. This one might be for trucks or something, I'm not sure. But that is why those are thickened where they are. So we're then going to go back down to the reinforcing requirements. So all the way back down. And so we want the reinforcing requirement for CF6. First thing to note, what is CF6? So that is continuous footing number 6. So a continuous footing will go around the building basically continuously. There might be different kinds of it, but an example of an isolated footing, which might be easier to start with, is this. So this is F5. So this is isolated footing type F5. There's another F5. So every F5, this looks like it's probably about 2 feet by 2 feet. So it's going to be 2 feet, 2 feet, F5. And then it's F5, so you know it's exactly those dimensions. F5, exactly those. There's an F4, so that one is a little bit smaller. There's an F6, so it's a little bit bigger. So everywhere you have F4, you know it's exactly a certain dimensions. But you don't know what those dimensions are. So in order to do that, you need to find a footing schedule. So just like there are door schedules, there are footing schedules. So we're going to zoom out, and it's going to look like a little table, and it's right there. So there's our footing schedule. So we know we have 3 types of continuous footing, and 3 types of isolated footing. So CF versus F. Width is going to be 2 feet for this one, and length is just going to stay continuous because it doesn't have one set amount. So it's just going to go around until it either meets itself or changes into a different type of footing. So all of these, so see that CF2 is showing all of this is CF2. Then we're going to go back. So we want CF6 reinforcing requirement. So this is telling you CF2, width of 2 feet, length is continuous, thickness is 12. So that's telling you how deep and how wide. The reinforcing, there is no reinforcing at the top of CF2, and there are 3 number 4 rebars continuous at the bottom. So it might be easier. So CF6, here's the answer. Reinforcing is number 4 at 12 inch each way, top and bottom. So that means there are number 4 rebars at 12 inches, so it's going to go rebar 12 inches, rebar 12 inches, rebar 12 inches, going each way. So it's good to just understand what this means because you can look at this and write down the answer without actually understanding it. So they're all number 4 rebar. So a good example, the footing 6A has 8 number 4 going each way. So it has a very specific number. So these are saying every 12 inches put a piece of rebar because this is a footing with an indeterminate length. So it's just going to give you, this is called an OC requirement, an on-center requirement. So every 12 inches on center, you need to put a piece of rebar. This is telling you you need 8. So this is giving you the specific number that are needed. So we're going to keep going down and we're almost there. Explain the difference between the 3 types of line in this picture. So I tried to make the arrows as best I could. So this is your grid line. So it's going to show you that solid line and then the little break and then a dash line. So it probably would have been better to have a bit more space on this one, but that's a grid line. Then you've got a foundation outline or a hidden line if you'd like to call it that. So it's the dashed and then the actual structure, which is your CMU wall. This one right here, think about that for a second. What goes diagonal? And that's a drainage line. So that's a sloping one. So that's showing you that this is going to slope this way. So this is probably in something like the service bays or a bathroom where you're going to need to slope it. All right, our final question is more of an estimating one than a reading drawings one, but we're still going to do this. So conduct a quantity takeoff for type F5 footings. Determine how many cubic yards of concrete is required, include 5% extra for waste and spills, and show your work. So the first thing we need to find out is how many F5 footings. So that's what doing a takeoff means. So it's going to the drawings and taking off those quantities. So F5 is an isolated footing, which means it's not going to be in this area. These are all continuous footings. I talked about it a little bit earlier, and it's right here. F5. So all you have to do is go through and go, all right, there's 1, 2, 3. Keep going, and there's none there. Go down. 4, 5, and 6. So there's 6 F5 footings. And then figure out the cubic yardage in one footing. So go back to your footing schedule, and an F5 footing is 5 feet by 5 feet by 12 inches. Watch that right there. It's not a 12-foot footing, it's a 12-inch footing. So that means that it's going to have 5 by 5 by 1 cubic feet, but I want cubic yards. So in order to go from cubic feet to cubic yards, you divide by 27. So even though I solved this, I'm now doing it differently. So I did that down there. So if we're going to go in order of this, you have 5 by 5 by 12 inches for 25 cubic feet, 25 cubic feet per footing, 6 footings total, means you have 150 cubic feet. So all I did was take one footing times the number of footings and I get the total cubic footage. Then I added in that 5% extra for waste to get 157 cubic feet. and then I'm dividing cubic feet into cubic yards to get my total answer. So it's 27 cubic feet per cubic yard because it's going to be 3 by 3 by 3, which is 27, and you get your answer of 5.83 cubic yards. So that's all we have for this assignment. Hopefully it's helped you understand drawings a little bit better, kind of critically thinking, all right, is this something where I need a dimension and I'm looking at a floor plan? Is it a concrete structural question where I need to be in the foundation? Is it an elevation where I'm on the outside, cross section on the inside? Is it going to be a list of information like a door schedule? Is it general information like a note? Is it somewhat specific like a keynote? And where do I go if I need to find it? A good thing to know, you can also just Google things. Chances are if you Google what does this symbol mean, something will come up. There's something different on every set of plans, so no one really knows everything there is, but hopefully that was enough to give you the baseline of how to read construction drawings.